So today we're going to learn how to add and subtract rational expressions, which is more challenging and requires a bit more thought than multiplying and dividing rational expressions. Similar to adding and subtracting fractions is harder than multiplying and dividing fractions. So with that in mind, we are going to start with some very basic math review. Sorry if some of you feel like this is a bit elementary, but what I want to do is show you the relationship between what you know and what you're going to learn. So thinking about when we add and subtract fractions, if we have 2/3 of a pie, for example, how can we combine that with, and let's just to make this simpler, 1/5 of a pie? And I don't know how to do fifths very well. Okay, so we have that into 5 pieces. We wouldn't be able to combine them because what we're trying to combine are unlike terms, similar to trying to combine an x and a y. They're unlike terms. So in order to get them to be like terms, we need a common denominator. Of course, the way that we do that is by finding the least common multiple of the denominators, which would be 15, multiplying by a special form of 1, because you can't change the value of the fraction. You can only change what it looks like. So 10/15 is the same value as 2/3. They're just cut into different sized slices. And same for the 7/5 equals 21/15. And then remember, the denominator is basically tells you how many slices the pie is broken into, and the numerator tells you how many of those slices you have. So the amount that it's being sliced into, the denominator, doesn't change, and we combine our numerators, which are now like terms. Now I want to go through another one because in this case, in our first case, 5 and 3 didn't have any common factors, but 9 and 6 do. So I want to kind of go through this thinking about it another way. We can break our 9 into 3 times 3, and our 6 is 2 times 3. So what is our first fraction missing? It's missing a 2, so we'll multiply by 2 over 2. What is our second fraction missing? It's missing a 3, so we'll multiply by 3 over 3. So we don't have to multiply our first fraction by 6 over 6 because they already kind of have some common parts. So 8 over 3 times 3 is 9 times 2 is 18, minus 30 over 18 again. And then we can combine our like terms. And in this case, we would continue to simplify because negative 22 and 18 have a common factor of 2. So we'd get negative 11/9. So what I want to show you now are the steps for the process for adding and subtracting rational expressions. So I don't actually have a right-hand column on my notes today because these are the steps and there's a lot to them. So similar to what we just saw with regular numbers, when we add and subtract rational expressions, if it's subtraction, change it to addition and distribute because it is much easier to keep track of addition than subtraction. Factor everything if you need to, or if it's possible. Multiply by that special form of 1 like we just saw. Either, in my first example, the opposite denominator, or in my second example, just the missing factor. Simplify your numerator so that we can combine like terms, and then simplify your answer. Alright, so we're going to start with some easy ones where they already have a common denominator. So we add our numerators. And then we have to simplify. They have a common factor of x, so I'm going to cancel that out. And of course, domain restrictions. It's always important to think about when we've got a denominator, when we've got that variable in the denominator, what is the restriction? Well, x cannot equal 0 because you can't divide by 0. Next easy examples still have a common denominator, so combining like terms in the numerator after I distribute my negative. 9x minus 4x, and then our negative 12. And our numerator doesn't factor, so we have no common factors, so our only thing left is to talk about our domain restriction.